All right, well, I want to welcome everyone to Prescription for Better Buildings Phius 2021 Core Prescriptive Pathway. This session, as always, is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. And today I will be your moderator. My name is Brett Little. I'm the program manager here at the GreenHome Institute. And as always, these sessions are approved for many different types of continuing education units, as well as, in this case, Passive House US Institute. Thanks to them for that, as well as our certified green home professional in health and energy pillars, and AIA Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. We have a new membership benefit alert. Thanks to Green Builder Media, we are going to send you some amazing monthly booklets of green building, everything you want to know, new products, new ideas, new ways to build, hot off the press, something real, something tangible. You don't see that too often anymore. Once a month, if you're a member of GHR, you become one today, they're going to send this to you every month, and you get it in your hands and you can read it in the real world. And then also, we've got the Sam Rashkin presenting Housing 2.0. I can't believe it. Over $1,000 off the ticket price if you become a GHI member. So support our mission, become a member there. The link's down at the bottom, and get some cool stuff. I mean, you got to check it out. And as before we head over, I got to say a big thanks to our top tier sponsor, April Air. They're going to help your clients stay healthy, humidity control, temp control, air purity. Water efficient humidification is a win for health and water conservation. It's really dry. I'm cracking here. And, humidity is what we need to help protect us from airborne viruses to some extent, they're finding. Energy efficient dehumidification paired with right size heat pumps can keep air feeling good, cooling it down, set higher points for dehumidification. You can have set higher heat pumps on your thermostat to save more energy. MERV 13 plus filtration captures particulates of growing concerns such as airborne viruses, PM 2.5, wildfire smoke, it's coming, sadly, VOCs, dust, and more. Check them out over at aprilair.com. And then also, thanks to our top tier sponsor, Ava Windows, they've got some super advanced windows that are going to help you meet Passive House, I believe, and get energy efficiency. R7, we're talking about UPVC and aluminum if you want recycled content. So you can check them out at avawindows.com. And with that, I'm super excited to be having someone back from Passive House. I think we've had folks from Passive House on now. Maybe this is the third or fourth time. Usually, I think Lisa White usually joins us. So it's always great to have someone new on. And, it's important to know that I just got to stress it more often than anything before we get into this, is that you need to set Passive House as your target on all of your projects starting tomorrow, right? Set it as your target, because the worst that can happen is you can only go down from there. If you don't set Passive House as your target, you'll never get there, because you can't go up, right? You can't go, the budget never goes up. Set Passive House tomorrow, certification, single family, multifamily as your target. And then let them tell you that you can't make it, right? Do it. And let John explain to you why that's important. So before we get into it, I want to know a little bit more about who we have here with us today. So I'm going to launch this first poll. How familiar are you with Passive House certification? Because you might be afraid to set it as your target, but how familiar are you? We're going to help you figure that out today. And then we'll give you a better sense of that. So we've got 70% answered right now. So I'm going to end that poll, and hopefully you can see that, John. It looks like we've got people kind of more on the familiar end in the somewhat area. So that's good. So you're going to be learning something new on how to implement it here today, especially on the single family side. And then again, just getting a sense for who's joining us. What typical types of projects do you get involved in? So we're talking single family, multifamily, mixed use, high rise, renovations, commercial. They all apply to Passive House. So which ones are you typically getting involved in, or if not all of them? So we're at 62% voting, we're hitting at 70%. So again, looks like we've got a nice mix, but a lot of single family folks here. So it makes a lot of sense. So anyway, John Locher, he's an architect and certified passive house consultant that's passionate about making better buildings through Phius certification. He is on the Phius certification team and is a CPHC with WUFI and a WUFI energy modeling instructor. So with that, John, I'm going to hand it off to you, and please do take it away.
All right, beautiful. Thank you, Brett. That was a great introduction. A lot of good energy here. I really appreciate it. Let me share my screen and we'll just verify all this is set up correctly. Hold on. Seems my computer's thinking for a second, so just let me know. Can you guys see my screen? Good. All right, great. So again, thank you so much for having me. My name is John Locher. I've been a CPHC trainer with Phius since 2016, teaching the CPHC course, the WUFI course. I've also been a CPHC since 2014. And kind of practicing in the realm of single family residential, non-residential, multifamily. So any type of Phius or sort of certified passive house typology, I've worked on it. And what I'm going to present today is what I am personally very, very excited about from the perspective of both scaling up the amount of passive house work that we can do, but also greatly kind of simplifying that process and addressing some of the roadblocks that we saw before. So this especially hits home for me really, really nicely, because a lot of the work that I work on is single family or kind of a smaller building typology. And that's exactly what we're going to see the prescriptive path is really good for. So as you can see, the title of the presentation I'm going to give today is Prescription for Better Buildings Faster, right? So it's not just that we're making better buildings. We kind of know how to do that already through the Phius certifications, but we need to find a way to scale this up and do it a lot quicker. And that's exactly what we're going to talk about today. And the intent is to give you an idea of what this looks like from start to plaque, as I call it, right? So it's the design isn't over, in my opinion, until you have the plaque mounted, right? There's even a little bit of kind of admin you might have to do just to make sure you get that plaque mount to the right place. So we're going to talk about all the necessary elements that you need in order to actually get your project certified in a much more expedited way. All right, so the overview, first we need to talk about what is the prescriptive path. Right? What is the protocol and what is the design intent behind that protocol, right? So kind of what is the context that we're pulling in order to make modifications to actually create this prescriptive path. We'll talk about the criteria development kind of, along with this idea of protocol design. Where do you get started, right? So like what documents do you need? What website do you go to? How do you just start that process? And then through a series of kind of case studies that I personally worked on, we'll take a look at these various principles of the prescriptive path, just to highlight some important things that you guys will need to know as practitioners. And then lastly, before I kind of send you off into the world, I'll share my contact information and a couple of useful resources for you as well. Okay, so first, let's back all the way up, kind of big picture here with prescriptive path. So Phius as a certification body has officially been certifying buildings as Phius for over 10 years, right? So we have a decade of data. If you look onto our Dropbox folders, there's quite a bit of information there, right? So we have information on some of the earliest projects all the way to the projects that we're currently working on in certification. So we have a really large library of information that we can kind of lean on in order to make some of these more general prescriptive requirements. And then embedded within that is the fact that we've also done this certified passive house way of building in multiple climates, right? So we're seeing a bunch of really nice certified passive houses all throughout the country in hot and dry climates, hot and humid climates, really cold climates, heating dominated climates, more moderate climates. So we can see that Phius as a design certification is actually really beneficial and cost optimized to our climate, right? So we're, again, able to lean on this information, which helps us create the kind of backbone for this prescriptive path. The second kind of design intent here for the prescriptive path is that we need our CPHCs. Speaking as a CPHC myself, the amount of time that we need to commit to a single project can be quite long, quite extensive, right? It might be up to 2-3 years, even for a very small project that you're kind of going in and out of the process. The other thing is that the current design process requires a lot of deep work, right? It requires, when we are working on it, we need to be like really, really focused so that we're not letting anything fall through the cracks, right? So we have this kind of long period of commitment to each project, but we're also requiring like really deep dives when we do have to get into it. So we kind of identified that this could be seen as problematic, right? When we want to scale up the amount of Phius projects in the United States and go beyond the borders of the United States as well. How do we start to rethink our certification body so that we're freeing up our CPHCs, right? And we're also reducing that barrier of entry for CPHCs. So we know that we want to scale up as a certification body. What we need to do is first address the CPHCs, which makes up our largest percentage of Phius professionals in the country. We want to reduce that pre-certification timeline and also reduce the pre-certification effort, right? Now, for the other Phius professionals, our builders, our raters, verifiers, we also want to open up the possibility of them to certify projects on their own, right? So previously in our model, a rater is super important for certifying a project, but we also need that CPHC for the pre-certification, right? We're going to talk about this a little bit more in a few slides, but we want to open this up so that a contractor can work with a client, apply these passive house methods, right? And use our prescriptive checklist, and a builder or a rater could actually submit their prescriptive checklist in order to pre-certify a project, right? So we're giving those kind of skills to our raters, builders, verifiers, as well as our CPHCs. Hopefully the intent here is that we're freeing everyone up so that the CPHCs who've been doing this forever can focus on larger, more complex projects. And also we can get more people eligible to pre-certify our projects. Talking a little bit more about reducing that barrier to entry, we want to create that accessibility for more CPHCs, certified passive house consultants, like I said. What we're seeing around the country right now is a lot of people outsource their energy modeling, right? If you've gone through the CPHC course, you've learned WFI, right, which is our primary energy modeling software. But you've learned that in about 2 days. It's about 8 hours of content. And you're going through for a specific project really, really rapidly, all while preparing for the final exam. So the result is many people don't retain all the skills they need in WFI, requiring you to either kind of get back into it and invest personal time to learn that piece of software after your CPHC, or what we're seeing is you outsource it, right? So we lean on those couple people who are doing a lot of energy modeling, and we kind of lean on them as experts. right? But again, that creates a kind of a bottleneck because we have X amount of CPHCs, and only a small proportion of those CPHCs actually know how to use WFI effectively. However, well, I'm assuming here that every CPHC has the ability to fill out a spreadsheet, right? So if we look back to LEED, when LEED was first introduced, that kind of spreadsheet-based certification system is very accessible for many, many people. And that's what we're trying to recreate here for the prescriptive path. We're removing that investment in energy modeling. So we obviously have time, training, and resources associated with doing that. Whether you're training yourself, you're investing in an employee to learn it, or you're investing your actual money to enroll in a WFI class, right? Which we do offer. And again, I'll talk about that a little bit more. But we also have this, the nature of the historic performance path, where we're integrating energy modeling. We have to make a design decision, test it in the energy model, go back, change our design based on the feedback of the energy model, and we kind of go back and forth, right? Rather than the prescriptive path, which it just tells us what to do from the very beginning, right? So we check that box and we move on. So there is a different level and investment in timeline. And like I said, it also allows more Phius professionals to submit for pre-certification. We want to scale up volume very rapidly as far as passive houses go, certification. So the prescriptive path is limited to single-family homes. However, it does support the rapid development of single-family homes. We've seen, again, this climate-specific standard very successful in the US over the past 10 years. So we're able to essentially say for each climate zone that we're looking at, what is an appropriate R value for the walls? What is an appropriate U value for the windows? Again, kind of taking conservative guidelines from all of the data we've collected. It's also a very cost-effective way to scale up large community development, right? So in the past, let's say you wanted to build 10 identical homes, all on one kind of subdivided tract of land, you would still need 10 energy models because we're getting so specific about orientation, shading elements, etc., right? The prescriptive path starts to abstract this enough that you can have one prescriptive checklist for each of the, for just that one home typology, right? As long as those buildings are the same that you're developing, you can use that same prescriptive checklist over and over and over again. And along with that, that feedback loop, right, that we see in the energy model is eliminated, right? We follow the prescriptive checklist and make sure that the model home that we're designing is the same and being repeated as a unit. And then again, we can use that checklist over and over again.
John, so just to clarify, when you get these large, like 4 or 5 different home types, but they have all the same sort of sustainability features, or in this case, energy efficiency features, even if they're different home types, as long as they have the same features, you can just use one checklist. Is that what you're saying? So
the checklist is dependent on the form of the building, right? So we'll do like an area of envelope takeoff, which we'll see in a little while. But if we have, a development and it has, I don't know, two home types, right? Even if one is facing one direction and the other is facing another direction, that would typically lead us into 2 energy models because of orientation. But with the prescriptive path, we're kind of squinting our eyes a bit, right? We're kind of generalizing some of these decisions. So the same building type could be repeated, even if the orientation is slightly changing, we could use that same prescriptive checklist.
Great. And then for those, the few who did join who are new to all this, can you just briefly say what WFI is,
yes,
what it means? Thanks.
Yeah, of course. So I don't really speak German at all, but essentially WHOOFI is a German acronym that essentially translates to heat and moisture transients. So what WHOOFI is good at doing is looking at the relationship of heat in our buildings and moisture within our buildings to both calculate total energy consumption, which is how we check our Phius targets, but also check durability within our buildings, right? We all know moisture has potential to create a lot of problems for us, especially when we have a high performance thermal envelope. Okay. So again, just, you know, I don't want to beat this over your head too much, but the we have an expedited certification process here, which is really significant. Again, speaking as a CPHC, I have at least worked on about a dozen prescriptive path projects at this point, and actually comparing the timeline and the amount of investment of my time towards the prescriptive path versus the performance path is really, really significant. So what we're looking at here is a sample project, kind of unnamed for a reason, but what we can see is that there's a period of time kind of right here where the architect and the energy modeler have to go back and forth and back and forth and back and forth, right? Kind of coming up with a design, testing it as maybe a feasibility study or multiple rounds of just revision in order to really hone in our specific design. So what the energy model does is allow us to really on a fine, like a very fine scale, make small adjustments. And as a result, we get this back and forth that's very extensive. Then we go into a back and forth with Phius, right? So we submit our project to Phius for certification. They review it, they send back comments, we make changes, send back the revisions, and we go back and forth, sometimes up to 3, 4, 5 rounds of review. Each of those rounds of review has 6 to 8 weeks of turnaround time associated with it. So you can see both the kind of internal back and forth takes a long time, and then the certification back and forth takes a long time as well. Now, when we move down to the prescriptive path, there's 2 things going on. One, we remove that back and forth between the energy model and the design because the targets are very clearly identified from the very beginning. So you just look at your prescriptive checklist and you say, this is what I need to check off, right? And then you design for that. So we kind of solidify, you know, this whole period up here into a much shorter time period because we don't have to go back and forth and create our energy model. Just to get you a kind of quick picture of what exactly you'll be looking at.
Great, thanks.
You're welcome. All right. So, you know, this is actually a perfect segue here. Right now, the focus is on single family. So what's allowed in the prescriptive path are single family detached homes. And then we also allow side-by-side duplexes, right? So great example here. This is a rendering from a project in Columbia County, New York, worked on by a number of kind of design professionals, but it's for Habitat for Humanity. So in Columbia County here, where I am in New York, we've certified 5 duplex projects like this through the Passive House Institute US. Now, from experience energy modeling these, I can tell you it's a lot of work, right? Even though every single home is identical, we're always dealing with the same climate conditions. We are dealing with different orientations, but I have to recreate that energy model every single time that we get a new project site. With this prescriptive path, I can fill out for this home that we're seeing on the screen, I can fill that out once. And then all I have to do is verify that all of the points along our prescriptive path are identical for the new project, right? There's no more need for an energy model, et cetera. So this is really significant for this particular typology. Like I said, we are anticipating in the future to kind of scale this up to multifamily as we have more multifamily projects and data that we can actually lean on. There are some other things that we need to be aware of as far as this criteria. For the first time potentially ever, there's much more of a focus on the form factor or the compactness of our building, right? And the reason why I'm saying this is, finally coming into our focus is because our energy models just do this for us, right? Our WUPI model, which we use for Phius certification, just takes into account the form factor into its calculation, right? But it never makes it very obvious and says, hey, you want a more efficient building, maybe you need to simplify the envelope. Maybe you need to reduce some of these bump outs or bump ins a little bit. Even our PHPP, which was used historically for passive house verification, through the use of the calculations that are embedded within both of these types of energy models, we're looking at compactness. Now, with the prescriptive path, since we don't have this energy model, we need to actually be a little bit more aware of compactness on our own. Again, we're going to see this as in an example in a few slides. So we're essentially limited to a certain amount of building area, envelope area, which is based on our square footage of interior area, right? The other thing is we're trying to control the density, the occupant density of these buildings as well, right? We see problems when we get into this McMansion typology, very little amount of people in a very big building. Again, that really kind of takes us outside of that data pool that we're comfortable with, and would get us into more of a performance path. 900 square feet, essentially the ICFA per bedroom, or ICFA per person, that's still a lot of space. If we get into more kind of high density multifamily projects, we might be looking at like 200 to 300 square feet per person, or per bedroom. So 900 square feet still gives you plenty of wiggle room. There's also some just really hard requirements. No fossil fuel combustion equipment, no jetted tubs or indoor pools, no natural draft fireplaces. As you can imagine, we don't have to go into this in too much depth, but these are creating conditions inside an air-sealed envelope that we can't, with confidence, deal with without an energy model. Air tightness is also going to be very critical for us here. So traditionally, this was always a focus in passive house building and the Phius standard. We're seeing an increased air tightness here, so a more strict air tightness limit of 0.04 CFM per square foot. That extra strictness is really helping us ensure that we're meeting those energy targets that are outlined in the prescriptive path, right? So it's taking a little bit more of a conservative approach here. Brett, you had a question?
Well, so, there's still the old number that's been floating around, right? And it doesn't seem to go away, the sort of 0.6 ACH, right? It still floats out there.
Yeah.
So I'm wondering if you can just speak to how that compares, but then also I thought you all were a CFM of enclosure, but this one actually looks like it's full on square foot. So maybe, I don't know if you can briefly just speak to those differences.
Yeah, so first, the CFM per square foot, that's per square foot of building envelope. So that's really important here. Essentially, for every single square foot, we're allowing 0.04 CFM through that, right? The performance path has an air tightness limit of 0.06 CFM per square foot, which is closer to that 0.6 ACH 50. In fact, it kind of roughly calculates over, depending on building size, of course, two different metrics, really. At Phius, we use CFM per square feet because it really helps us compare that air tightness between different sizes of buildings. Without going into the calculation, it's kind of hard to explain it beyond that. But when we kind of distill it down to CFM per square foot, we can compare the air tightness of a ADU, accessory dwelling unit, a very small building, versus hundreds of units multifamily building, right? And it gives us in the same units so we can compare those. So the 0.04 CFM per square foot that we're seeing is more airtight than the 0.06 CFM, which is equal to the 0.6 ACH. I don't know exactly what it converts to in ACH 50, but know that it is a little bit more strict than what we're typically requiring. Also know that for a single family home, this is very achievable. Most of the projects, at least in New York that I've worked on, shoot for the 0.06 CFM, and they usually get at minimum the 0.04, if not exceeding that.
There was another question on they just wanted you to elaborate more on the less than 900 square foot value.
Sure. So that less than 900 square feet is really what it's really doing is helping control the amount of interior heat gains relative to the building envelope, right? So if we have a very large building with only one person in it, our energy balance is totally screwed up, right? We have like, I don't know, a couple thousand square feet per person versus 900 square feet per person. That means there's only one person in multiple thousands of square feet that are using appliances, moving in the building, generating heat, etc. Right? That affects our passive house kind of energy balance. When we get to that 900 square feet or less per person, then we're creating a higher occupant density, meaning we have more people in the building relative to the quantity of building enclosure, right? So we have more internal heat gains, which helps us meet our passive conservation targets. Okay, just a few more things on the air tightness. We also, within the prescriptive path, require a preliminary blower door test. So this is kind of a new thing, but again, with the kind of lack of energy modeling, we want to be able to catch things on site sooner, right? So this is a QAQC thing. This increased air tightness ultimately gives us, again, that buffer since we're not energy modeling. It gives us a more conservative approach that allows us to make sure that all of those kind of moisture risk issues that we potentially deal with we're very far away from those, right? So increasing that air tightness helps us increase the assurance that our building assemblies are going to be very durable. Relative to that durability question, the calculator or the checklist that we're using has a built-in assembly and window moisture risk compliance. So this is something that we see is overlooked constantly when people are certifying projects. There's a breakout window moisture risk calculator that very few CPHCs know about. And there's also very deep buried in the certification guidebook, moisture control guidelines for building assemblies that often people don't know even exist. So we wanted to simplify this process. Instead of asking our CPHCs to deal with an energy model and also know where all of these other kind of breadcrumbs of information are, we're pulling it all into the checklist, and the checklist automatically verifies that we're hitting these moisture risk compliance items. Also with QAQC, our quality assurance, quality control, we have the high performance staircase, which essentially gives us a view of Phius alongside all of its co-requisites, right? So our Phius rater and verifiers are still extremely important for the prescriptive path. They verify that we're meeting all of our compliance for building energy code, Energy Star, zero energy ready homes, EPA Indoor Air Plus, EPA water sense criteria, and then obviously our Phius criteria on top of that. Okay. So the past 45 minutes, we've really looked at what are the intentions behind the prescriptive path. Now let's look at just getting into it. How do you actually go and do that? And again, this is relevant to people working on multifamily or even non-residential projects as well, in that it gives you a starting point. It just lists out all of the things that our project needs to verify. So what we're seeing here is what we're calling the core prescriptive snapshot. You can find this at phius.org. And essentially what we do is put in our state up here at the top. Everything in orange is what we're going to be changing. Our locality within the state, that automatically tells us what climate zone we're in. Then from there, we put in the size of our building in ICFA, or floor area, number of bedrooms, and number of stories. And that spits out for us what is our ICFA over bedrooms, so that occupant density we referred to. You can see here our limit is 900 square feet per person. This particular example calculates out to 375 square feet per person. So we're well within the limits there. It gives us a maximum envelope area. So we calculate our ICFA, or the floor area of our building, and it tells us how much envelope area we can have, right? Again, referring to the form factor of our building, or that compactness. It'll also give us solar heat gain coefficients, projection factors for fixed overhangs. If we're in a climate that needs to kind of modify overhangs and solar heat gain coefficients, gives us required U values, R values, etc., right? As well as some mechanical requirements. So it's just really laying out all of the prescriptive checklist items for us in a very early stage, perhaps without even knowing what our building looks like at this point. We would take that snapshot and we can go right into design from here. So you work with the architect, design your building. We would then formalize that design into the checklist, which goes into a lot more detail. From that checklist, we should be able to receive pre-certification through Phius. We can then go build the project, and through the construction and paired with the rating from our Phius rater, we can receive final certification, right? So hopefully this is kind of just review for most of you, but we can see that that path to certification from that snapshot to final certification is very similar to what we're doing in the performance path. We would submit that prescriptive checklist, right? So that's going to be that verification from the CPHC that everything is being satisfied. We will submit our construction drawings as well as takeoff drawings. And then we will submit our data sheets, right? So again, very similar, the prescriptive checklist is replacing our energy model in this prescriptive model here. Zooming into that prescriptive checklist, we can see it's organized into 9 sections. So we go from our general information, air tightness, compactness, solar protection, thermal enclosure, and then we go into our mechanical systems below this. And this gives you an example, for instance, our general tab up here, we have to verify all of our co-requisite programs are satisfied. We would have to verify no jetted tubs or pools, no natural draft fireplaces, etc., right? We would verify that our target is 0.04 CFM per square foot. We would verify that we know that there's a preliminary blower door test required, and we just go down the checklist just like that. Oops, let me delete these. So we have a couple case studies just to give you guys an idea of like the type of projects that Phius is looking at right now to certify in the prescriptive path. I've worked on every single one of these, so they're kind of limited in the Northeast right now, but we have a nice range of some climate zone 6, 5, and climate zone 4, and we can see the actual impact on the due to the climate on the performance, or I'm sorry, the prescriptive requirements. So a quick summary, not every project is going to qualify for the prescriptive path. Anything that we're seeing with a green arrow next to it is in the queue to be certified as a passive house. However, only the top 3 are on the queue for the prescriptive path. The projects in Wellfleet, Massachusetts, and Cornwall, New York that we're seeing down here with the red kind of, I don't even know what that symbol is called, but we can see that they ran into a couple different snags, right? So the Wellfleet project could not satisfy the compactness criteria. So it had too much exterior envelope relative to the amount of interior floor area. The Riley residence, for kind of design reasons, could not meet the requirements of the thermal enclosure. The Pleasant Hill project could not meet the compactness either, right? It had a lot of lofted spaces inside. And then interesting, that final project, the Wild Oak Passive House in Blacksburg, Virginia, actually met all of the prescriptive requirements, but decided that they really wanted to see what that energy model looked like, because source 0 certification was really important to them. So they choose the performance path instead of the prescriptive path. So I'm just going to go through each of these principles kind of quickly. We're kind of getting close to the end of the hour here. Air tightness, as we discussed, is really important here. I'm going to kind of skip over that, but the key difference, as I already said, was we're increasing that air tightness. So we go from 0.06 to 0.04 to take more of a conservative approach here. That compactness is also really important. Again, that's a ratio of the floor area of the building to the square footage of the exterior envelope. Phius uses a notional compact building as their target here. So that assumes 12 feet per story, a window to door aspect ratio of about 3, and evenly distributed floor area per level, right? So it's assuming a very kind of rectangular, boxy building form. We can see here on the bottom the relationship between height of floor to overall building envelope, right? So these are 3 examples, the same square footage as far as the floor area on the inside of the building, but as we increase the height of the floor, we can see that envelope grows and grows and grows, right? So same livable area in each of these 3 examples, but the project with the kind of double height space obviously has a much larger area of envelope, which can create problems for us in the prescriptive checklist. So this is that example in Wellfleet, Massachusetts. It was already under construction when the prescriptive path came out. So we tried to kind of retroactively apply the prescriptive path to it. Unfortunately, it didn't work, right? So we can see we have a lot of building complexity here. We have some double height kind of lofted spaces. The result was a total area of envelope that was above the kind of cutoff point that was outlined in the prescriptive checklist. For solar protection, the climate zone that we're designing for is super important. Climate zones 5 through 7, you guys get out easy. The only thing that we're verifying is that we have a net gain score, right? So we're essentially just taking area takeoffs of the windows and verifying that we're not overglazed on a single building elevation. Climate zone 4 you get to deal with all of the solar protection elements. So we have a max solar heat gain coefficient for climate zone 4 and below, and we also have to deal with that net gain score. When you get into climate zones 0 through 3, we're getting to more cooling dominated climates, and we need to deal with fixed overhangs as well, right? So depending where you are in our ASHRAE climate zone maps, we have to deal with solar protection in different ways. Again, the prescriptive checklist will tell you in a very, very clear way exactly what you need to do for your particular climate. Principle 5 would be our thermal enclosure. So we have a section in the prescriptive checklist where we select our assembly types. This is looking at just our typical walls. So we can see here we have many different wall types to choose from. Double stud wall assemblies are allowed, except only interior load-bearing double stud assemblies for some hydrothermal reasons that maybe you guys can email me about after this presentation. We can actually put the thermal resistance values of all our different insulation into the checklist. And like I said, it's really nice because it just tells you if you're in compliance with the Phius certification or not, right? So we have a required R value over here of R36. That's based on the climate that we entered. We can see the calculated R value for our particular assembly. And then do we meet both that required R value as well as the moisture control guidelines, right? So again, it doesn't allow us to even make that mistake to oversee our moisture control guidelines. Included within that is obviously going to be our thermal bridging and reduction of thermal bridging. So we have to very clearly define what is continuous insulation, and that's also included in this checklist. Generally, you want to maintain at least R10 continuously around the envelope of the building. Continuous insulation would be defined that as insulation that's uncompressed and continuous across all structural members, without thermal bridges other than fasteners and service openings. So we are including or accounting for some thermal bridging. I apologize, guys, we're running out of time, so I'm going to go through this a little bit quicker. We have U-value requirements, again, depending on climate. I think that's pretty self-explanatory. That's dealing with essentially your worst window. Your worst window in your project has to satisfy this U-value requirement. As long as the worst window satisfies this requirement, everything else in the project is fine. Moisture risk limitation, both for windows and walls, is automatically verified. And the following couple slides, I'm going to sum it up here. Essentially, we have that checklist for mechanical ventilation, mechanical systems, and lighting, miscellaneous electrical loads, and domestic hot water, right? A series of criteria that we have to meet. Okay, so we got like 2 more minutes here. I just want to give you guys some resources. So we have the certification guidebook, which can be found at phius.org. This also gives you step-by-step instructions for the prescriptive path. We do have a number of professional trainings coming up. So we have the CPHC, the Certified Builder, Raters, and Verifier trainings. You can find specific dates at phius.org. We have, if you're still interested in Performance Path, we have a number of WFI trainings, actually brand new for this year. We have some beginners courses, which is a 10-hour total course spread over 3 days. We have advanced single family, and then brand new and advanced multifamily course, which single family I think is happening the very beginning of March. Multifamily is coming in April. And we're also really excited to announce more formal training for the prescriptive path. The dates are kind of escaping me right now, but it is a 4-hour workshop, 1 day online, intended to be about half of your workday, where we go over a presentation, similar to this, looking at the prescriptive path, but then we actually dive into a project. So you're given a sample project and we together fill out that prescriptive path in depth there. So it gives us an additional 3 hours to kind of get into the weeds. All right, so that was a mouthful. I apologize for going so fast. Just want to thank you guys for your time, and I believe we can open it up for some Q&A at this point.
Yeah, hey everybody. Just real quick before we jump into Q&A, thank you, John. For those of you watching this in the future, not right now, on demand, please take that quiz with an 80% passing rate to pick up your CEU. You can check that out on our Think Epic channel or USGBC or wherever you might be watching this in the future. For those of you listening in right now, go to your spam in a couple days here and check for certain certs at gutenbergcerts.com, and you'll receive your formal certificate as long as you were here for the full 15 minutes for the CEU approval. So you can check that out there. Mark them as safe right now so you can pick those up. And we got a lot of questions coming in. We're going to try to get to as many as we can, so stick around. But if you have to go, again, you're good to go. But before you go, again, just a huge thanks to our board of directors, all of our speaker volunteers that we've had since 2013, hundreds. And thanks to our executive director, Jose Renya, and our top tier sponsors, Mitsubishi, Ream, April Air, and Build Equinox. They're all going to help you meet Passive House and meet green building certification and make your projects better. So make sure to check them out. So, John, I want to talk briefly, I think, because we slammed through mechanicals here at lightning speed. So let's talk about some mechanicals now that we've got, now that we're on the other end and we have some time, and
sure,
for those who love the mechanicals.
Yeah.
So just to be clear, is it still balanced ventilation with recovery for prescriptive?
Yeah. Is it possible? Can I share my screen again?
Oh yeah, absolutely.
You know, that to me is the really important kind of interesting stuff. So you want to bring those slides back up. Yeah, mechanicals, we're still dealing with balanced ventilation. So now that I have a little bit more time and I'm not watching my clock, the prescriptive path is broken up into the three final sections would be mechanical ventilation, our mechanical systems, so heating and cooling, and then kind of the rest, which is our catch-all. When we're dealing with mechanical ventilation, we are dealing with that balanced mechanical ventilation, right? So ultimately, like, same amount of air that we're bringing in from the outside, we have to be exhausting to the outside, right? So our CFM rates are always going to be balanced there. For the prescriptive path, it's going to be based on climate again, right? So this particular example up here is for climate zone 5. So we require an 80% sensible recovery efficiency, right? So you can also see there's a total recovery efficiency for your ERV, which in this case is NR, right? So there are a lot of, as we go through the prescriptive checklist, a lot of areas that might not be relevant to your particular climate. And we can just check those off as, okay, that's not relevant to me, which is kind of nice. There are some other simplifications that are going on with ventilation. Like before, we used to have to do takeoffs of our ducts that go from our ventilation system to the outside. We're still doing that, but rather than kind of quantifying the energy loss through an energy model, we're just saying, okay, you got 25 feet. You can either split that between 12.5 feet supply, 12.5 feet exhaust, or you can do 5 feet supply, 20 feet exhaust. So it's giving us a kind of limit as far as total length of those ducts, and we can kind of divide it up however we choose. So there's a lot of kind of abstractions like that that help us meet the prescriptive path. We're kind of limiting ourselves with the amount of systems, one, because this is focused on single family, right? So we kind of have only a certain amount of systems available to us there, but we're also not able to use any combustion systems. So we're really looking at air source heat pumps, ground source heat pumps primarily for heating and cooling, right? So you can choose one of those. Again, it will give you a climate specific requirement. A minimum COP of 1.8 at 5 degrees Fahrenheit. That gives you enough wiggle room to still really be able to select a lot of systems, right? And then we see the SEER for our cooling system as well. So again, really just tells you like a minimum performance value we need to hit for heating and cooling. And perhaps that last section, lighting, appliances, water heating, this is going to be the most kind of exhaustive, unfortunately. We really lean on the co-requisite programs here. So, for instance, our appliances or our fixtures, right? If we look at item 9.1.1.1 over here, give me my pencil. I don't know, for some reason it's not letting me mark up, but you can see all light fixtures would have to be greater than 83 lumens per watt, or we have an average efficacy, essentially allowing us to take a weighted average for all of our fixtures, right? So like our energy model will do all these calculations for us. Because we don't have an energy model, we still need to not necessarily take an inventory of how much energy we're going to use in the building ourselves, but we want to make sure that our appliances, light fixtures, anything that's using electricity is going to hit a certain kind of minimum. Appliances largely leaning on the Energy Star program, so that's pretty simple, and we were doing that with Performance Path as well. Water heating is really going to kind of force you into heat pump hot water heaters because there is a minimum UEF. We do have the option for solar hot water as well, but really it's going to prevent us from using like hot water on demand systems or other kind of electric based systems that require a lot of energy use for creating hot water. I guess one other thing I can add about this section is that we do require that all certified homes, Phius core certified homes, are EV ready, which doesn't necessarily mean that you need an EV charging station hooked up, but you need the capacity to install one in the future, right? So you need space on your breaker box, and you need a conduit that's going out to where you would potentially park an electric vehicle. So that's kind of an interesting, additional requirement that was added in order to start to complement the transportation sector as well as the building sector.
Great, thanks. There's a couple more high-level HVAC, but before we get to it, everyone is asking about the Phius code. Can you briefly hand that off to everybody?
Oh yeah, of course.
Keep getting into it. So, and I typed that code into the chat for those of you who need it, and those of you listening on demand, you will receive that code with your certificate. So, anyway, so on the higher level kind of question is regarding the recovery systems that have heat pumps built into them, and this may be a question more not just for prescriptive but for performance too. Are those allowed? Do they have any special considerations?
Yes, depending on the manufacturer. So there are certain devices like that have received the ratings that we need to verify that the numbers that they're giving us are feasible, right? Essentially that's what it comes down to. So theoretically, as long as you meet these different ventilation efficiencies, watts per CFM for ventilation, et cetera, that should not prevent you from any certain types of equipment, right? Whether it's a combined ventilation, heating, and cooling, or you have two separate systems like we kind of see traditionally. So yes, these can all still meet. I have seen a lot of questions about these in-wall like kind of ventilation devices, right? Without getting into the specific manufacturers. Now, those are also theoretically allowed, but you have to be very careful about the CFMs that they're capable of delivering, right? You still have to meet minimum CFM rates for bathrooms, kitchens, etc. So that would be my one kind of word of caution with using those in-wall systems.
Great. And you know, a lot of these systems that have the built-in heat pumps may or may not also have what we call smart ventilation. And we're going to be doing a session, just so you all know, on April 6th with a whole host of great folks, panelists on smart ventilation. But how does smart ventilation fit in with passive house, both prescriptive and performance? You know, basically the idea that these systems only run when there's pollution detected and then, you know, ramp down, right? Like whatever it might be, CO2, VOCs, PM 2.5, which hopefully in passive house you don't have, right? You're not burning anything. But how do you all is that built into your system? Can you recognize that? Are you sort of punished if you're not hitting a certain, like in most cases, if you're not hitting the 62.2 2016 threshold, right? Or I just use that as an example.
Right.
Like, what do you have any thoughts on that?
Yeah, that's a great question. I mean, frankly, I haven't dealt with that question enough. Even in the performance path with an energy model, I imagine it would start to affect some of our values like the watts per CFM, right? So that's going to have a direct impact on our primary energy. Just because of the amount of effort that the ventilation system has to go through at different times of the year. So I don't believe we have a protocol in place to quantify that just yet, but I would imagine as we start to see these systems more and more, there's probably going to be a protocol kind of made up, frankly, in order to account for it. The prescriptive path is not going to have an effective way to quantify something like that just yet.
Okay. Renovations. What do we do with prescriptive? Can we do it? Are we allowed? Sounds hard.
Yeah, I mean, renovations just in general are hard.
Sure. Just,
right?
Yeah.
But yes, yeah, I mean, theoretically, there's no reason that you could not do that with the prescriptive path. I mean, you're dealing with the same kind of detailing issues, you know, foundation to typical wall transition without lifting a building. Like, you know, there's never really, well, there's a lot of conversation that could be had around that. But, you know, as long as you're hitting those minimum R values and you're hitting the system requirements in the prescriptive path, there's no reason you could not apply it to a renovation.
Now, getting back to multifamily and how you define it, typically we define multifamily as usually 4 units. That's when you start getting into the commercial code stacked, right?
Yeah.
So people are kind of asking, you know, what about townhomes that are all attached, and how do you deal with that separation wall in the townhome? But then just confirming, do you all look at multifamily as sort of that 4 unit stacked with this program, or where do you sort of draw that line?
Yeah, I mean, you know, we include that side-by-side duplex. I wouldn't say we're necessarily calling that multifamily. It's really just like a step up from the single family. Yeah, and part of that has to do with this enclosure area. So essentially with the more repetitive kind of townhomes where we have like units in the middle, that's where it gets really hard to apply the current form of the prescriptive path, because there's such a small amount of exterior enclosure, right? If you're sharing 2 walls, you know, then you only have 4 surfaces that are exposed to either the ground or the outside air. So of course you're always going to hit the compactness requirements. Also, the thing to mention here is like the prescriptive path is based on our, you know, the assumptions that are based in about the way that we use buildings. And you know also that as we get to larger buildings, they become more interior load dominant. So the amount of occupants, what's going on inside the building, if it's non-residential, all of those things really change the energy equations in a really big way. So they really still fall outside of what we can do in the prescriptive path.
Yeah, good points. So, going back to the solar piece, there was a clarification question, and I wanted to add a little bit to that.
Sure.
The clarification was to explain net gain solar, but I wanted to add to that a little bit and talk about how you had mentioned us folks up where I'm at, especially 5 to 7 climate zone. We're kind of, okay, right? Because we don't have to deal, at least not right now, right? But the future, most likely with overheating.
Yep.
But what about the wintertime? We know we see so many passive solar homes that can basically be heated when that sun comes out in the dead of winter.
Yep.
Do you all require that also be done in these calculations? It sounds like you don't, but speak to, all that. Yeah.
Yeah. So the one thing that we do have to address as far as solar control in the northern climates, 5 up, is essentially the square footage per elevation, right? So obviously our south elevations are going to be important here. So essentially in the checklist, what it looks like is we have north, south, east, west elevations, and we're doing takeoffs for all of the glazing on each of these elevations. So there's going to be certain percentages that we're allowed, kind of window to wall ratio percentage on each of those elevations that we can exceed. So I think it's like 35% for that south elevation. Don't quote me on that. But essentially what that does when we're looking at that south elevation is it's going to say, like, we can't just make our south elevation all glass because we're going to cook in the summer, right? So yes, it brings in a lot of benefit in the winter, but we have to be reasonable. Just, I guess the dial that we're turning here is just what is the total amount of square footage of window, right? So it gives us 2 options. We can either, like in the case of a retrofit where the building's already placed, right? You don't necessarily have that nice south elevation. It allows us to not lean on those passive solar gains, which is really nice. But it gives us enough flexibility that if we want to tune it and get more into that passive solar world and really rely heavily on the benefits of solar heat gain, then we can also do that.
So obviously, one of the misnomers, and it's built into your name, right, is that you can't certify, larger buildings. So we know that there's huge mixed-use multifamily buildings certified. We know there are commercial buildings certified.
Yep.
What can folks, especially, what we find in practice is that small commercial buildings are really just single-family homes. The way they're built, they're just single-family homes with different operational usages. So the question, I guess, from our audience member here is, what about us doing small commercial? Can we use this? Is there something coming for us?
So you would not yet be able to use prescriptive, but you can definitely certify through the performance path. I've certified 4 non-residential projects that are essentially still single family residential scale. Now, what that really comes down to is just the internal loads. So the internal heat gains. And it's not only the way that we use things in the buildings, right? So for instance, we might not be cooking as much in the building, but it's also when those buildings are inhabited, right? So you don't have to worry about providing heat throughout the night because there are people sleeping in the building. You might be unoccupied over the evening, right? So it's not just how we're using the building and what's going on inside, but it's when that building is being used. That becomes really important for non-residential. But everything's there. I mean, there's plenty of non-residential projects being certified constantly. And yeah, it's all really laid out in the certification guidebook, to be honest.
So prescriptive, you want to make it easy, make it simple, simpler than performance. That was sort of the message you drove at the beginning. Okay, so are you still asking folks to get a HERS rating because that's performance? And then are you asking folks to go through the DOE Zero Energy Ready program? Because while that's not performance, that's highly prescriptive. And in many cases, people could argue very complicated. I know that the DOE is trying to fix it through this next version. They had a public comment for that. So you want to make it easy for us, or we still have to do a performance HERS rating? You know, what's the requirement?
Yeah, of course. Yeah, you're absolutely right. We still do have a HERS rating, right? I mean, that was kind of some of the beauty with Phius from the very beginning, is that we lean on these domestic programs that are trusted, right? Especially when we get into like incentive money and things like that, like you really want to know that you're leaning on a trusted kind of time-tested program. So that's the benefit there. But you know, I think this is kind of like the new frontier for passive building, in order to reduce the amount of time. And I would probably say that the QAQC process is something that needs to be addressed relative to this. So I would anticipate that being something that might start to change a little bit when we see the next version of this prescriptive path. Yeah, but that's about all I have on that at this point.
Okay, well, that's, you know, I appreciate it, and that's good to know that there's still I mean, at the end of the day, you still need to know your energy use, right? Which is what HERS will give you.
Right.
Which is an important number to know when you're making financial decisions, I would say. So still certainly built in there. So gosh, there are so many questions, so many great comments. You know, we're definitely not going to get to them all, but it would be really good if you can, you know, follow up with some folks here. I think they just, you know, wanted a clarification again, as to whether, well, first of all, I think someone was led to believe that the consultant, the rater, the verifier, and the builder all has to be certified, but I don't think that's true at all. But can you just speak to what you were saying with that?
Yeah, sure. So first of all, you're never required to have a Phius builder. You can use any builder you want. But the person who submits for pre-certification that says like your design is good, you can build this and you'll be on track, that person needs to be a certified professional. And then the Phius rater has to be certified. And I guess even more important than that, than being a Phius rater, they have to be a HERS rater or a BPI professional, right? So they need to be qualified to go through all the co-requisite programs. And then on top, they get a little extra training to be a Phius rater. So theoretically, in the prescriptive path here, theoretically, a rater could certify for pre-certification. And then it gets a little tricky because you probably wouldn't want the same person to be your QAQC guy in field, but it could very easily be an employee from the same office, right? So you could see how you could theoretically just have a Phius rater to certify through this prescriptive path. A CPHC is obviously ideal, and that would be probably the role that an architect would take on. So probably that's where we're going to see a little bit more, is a CPHC for pre-certification, a Phius rater for final certification.
Great. And then just some you know, some more clarification questions. If the prescriptive path has R value requirements, does that mean it cannot be used on mass wall buildings that depend upon the thermal mass rather than the thermal resistance?
You know, thermal mass gets to be kind of tricky without an energy model, right? Even with just the kind of static WFI model that we do for Phius certification, thermal mass gets really tricky. Yeah, I don't really know what to say in that situation. I think you're still going to have to meet your R values, your required R values. You're not really going to be able to account for an additional benefit of thermal mass. That's going to be kind of like something that goes above and beyond the certification, and we don't really have a way to verify that, unfortunately.
Yeah, well, good points. And a question here about someone had heard that glazing limits were 18% of floor area. Is that a correct metric, or is that kind of different depending on what you're doing?
That's a number that does come up. To be honest, in order to give you a definitive answer on that, I would have to look at more projects in different climate zones and see how the checklist actually modifies. But yeah, 18% per about your total floor area, that's something, I would expect kind of in that level for, climate zone 5, et cetera.
I guess there's a question here, and there's always a question, of course, about, what is the value proposition, right? I mean, we always get asked that in this line of work. It's a fair question for green or passive house or net zero, and going through all these additional processes. And sometimes the answer to that is, you have a client asking, so of course you get a job, you have an incentive, okay. But outside of that, I think there's a concern about the time, especially on the designer and architects, efforts for this. And so, I mean, is it really just more of a learning curve issue where you get through a couple and then this is just easy? I mean, what are your thoughts there with what the feedback you're hearing from other designers and architects?
Yeah. It's kind of interesting when this prescriptive path came out, I thought for sure my work as a CPHC would be completely like annihilated and everyone would be just using the prescriptive path, but that's not what's currently going on. Maybe just because people are like a little intimidated to get into a new thing. But the clients that I've worked with that I've essentially like done it for them the first time and then explained what I did, now are taking it and going off on their own. And these are people who have been CPHCs for a long time, but don't necessarily know how to use WFI themselves. So I think there's a huge amount of value where you can go away from this model of like a third-party energy modeler in order to, like, the CPHCs that are implementing this method right in-house can bring it all in-house. So that obviously is going to simplify things from a time perspective, the back and forth. But then also, that additional cost of bringing on another CPHC to be your energy modeler. So I think those are the kind of most obvious here. But, frankly, from having the learning curve of the prescriptive path, and then when I first became a CPHC, the learning curve of WFI, the learning curve of WFI is significantly more. I mean, I've worked on many, many WFI models at this point, and I'm still seeing things that I've never seen before, right? And every time you see that like new, like unique element, you have to learn something new. And I think the scope of the prescriptive checklist is just much more limited. So, wastewater recovery system, it doesn't really fit into the prescriptive path, right? So you can't necessarily take advantages of its benefits. But it doesn't mean you can't implement it in your project.
Yeah, fair enough. Yeah. What role does water conservation, especially the water conservation that ties into the water heater, play? I assume when you're doing WFI modeling, you can put in flow rates, but is it something that you have to look at in prescriptive?
So this again kind of leans on one of the co-requisite programs, the WaterSense program.
Oh, sure, yeah.
So WFI, we build out our plumbing runs in WFI in kind of a vague kind of abstracted way, but we try and, estimate those plumbing runs as best we can. And WFI will actually verify whether we're in compliance with the WaterSense criteria or not. In the prescriptive path, you would be leaning on your rater to verify that compliance. So it's not included in this checklist extensively, but there is an item that's just asking the rater to say, hey, do you meet that WaterSense criteria? So the work is still being done, just not as kind of in your face.
And what about what we call structurally insulated framing systems or insulated studs. How do those fit in, and can they be accounted for continuous insulation?
That's a really good question. I know that we have, well, we're limited to the types of wall assemblies that we can verify here, right? And the reason why we're limited there is because we're trying to not only verify the R values, but we're trying to verify the moisture control. So we're kind of limited by like the functions of Excel, frankly, right? So we choose like a double stud wall, and then it's going to, Excel will go into another calculation that says we got to make sure that our percentages are right and all of that. So when we get into non-standard wall assemblies or things, you know, kind of experimental wall assemblies, not that, you know, the system you mentioned is completely experimental, but it's outside of what we've kind of traditionally seen and had time-tested results for, then that wouldn't be allowed under the prescriptive path. So like, actually a great example would be that double stud wall that I mentioned, right? So if you have an exterior load-bearing double stud wall, the prescriptive path will not allow you to certify the project that way. The reason why is because we would ask you to provide hygrothermal modeling to make sure that that dew point isn't falling in that exterior stud, which is load-bearing, right? Last thing you want is condensation on your load-bearing wall, wood rot, and then your building falls down, right? So we're not saying that that's a bad, we're not saying that your building is definitely going to fall down if you do that wall assembly. What we're saying is we would like to look at that a little bit more closely. So we're just going to ask you to certify under the performance path instead, which makes protocols for energy modeling.
Yeah, great. Well, John, we are at our time, so I really appreciate you joining us and staying a little bit longer to ask a lot of great questions or answer a lot of these great questions. Where can people go to either contact you or learn more about the prescriptive pathway if they'd like to? Yeah,
so I'm going to put my my email again in the chat. You guys are very welcome to reach out through that. Take a look at the prescriptive training that we're going to be offering. I think that's going to be a really nice opportunity to work in small groups and actually fill out. So we'll get to look at each one of these checklist items in detail and discuss that as a class. I think that is really going to be super helpful in adopting prescriptive path a little bit more. Phius.org is always a good resource as well. Arguably too much information on there, but there is plenty of information that you can check out as well.
John, thank you so much. Passive House US Institute, go check it out. Commit to it. Make it your standard. See if you can make it. We want to leave you with that, challenge you with that. Thank you all for joining us. Stay safe and well out there. We're so close, and we're going to keep doing webinars, but we do want to see you all in person at some kind of event someday here soon. So let's get through this thing and you know, hang out. So take care, everyone. Goodbye.
All right. Take care, everyone. Thanks a lot, Brett.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.